Hi, I'm Ms. Hearn. Let's get started. In previous videos, we looked at what it meant for one number to be divisible by another. For example, we saw that the number 10 is divisible by the number 5. This notation means 5 divides 10. And the reason that 10 is divisible by 5 is that if you divide 5 into 10, you get a remainder of 0. For larger numbers, we also have some divisibility tests. Divisibility tests are an aid to determine whether a natural number is divisible by another natural number. We have tests for divisibility by the numbers 2 through 12, but we're not going to look at the tests for 7 and 11 because they're a bit too involved to be useful. The divisibility tests for 2 through 6 are on this slide. To be divisible by 2 just means that the number ends in the digits 0, 2, 4, 6, or 8. To test if a natural number is divisible by 3, all you have to do is add up the digits and see if that new number is divisible by 3. To test if a natural number is divisible by 4, you actually look at the last 2 digits of the number and see if those 2 digits are divisible by 4. In order for a number to be divisible by 5, it needs to end in a 0 or a 5. And in order for a number to be divisible by 6, it needs to be both divisible by 2 and divisible by 3. So, for example, is the number 2,984,094 divisible by 4? Well, to determine that, we need to check if the last 2 digits form a number that's divisible by 4. The last 2 digits form the number 94. Since 94 is not divisible by 4, demonstrated by dividing 94 by 4 and seeing that there's a remainder of 2, we can conclude that 2,984,094 is also not divisible by 4. Let's check if the number 4,355,211 is divisible by 3. This would mean that the sum of its digits is divisible by 3. If you add up the digits, you get 21, which is divisible by 3. So that means that 4,355,211 is also divisible by 3. Now let's use the rules of divisibility to determine whether 3,544 is divisible by each one of the following numbers. This is a question that appears in the homework assignments for the classes that I teach. Let's look at part A. Is 3,544 divisible by 2? In other words, is it an even number? If you said yes, you're correct. We know this because the last digit, 4, is divisible by 2. How about part B? Is 3,544 divisible by 3? If you said no, you're correct. 3 plus 5 plus 4 plus 4, the sum of the digits, is 16, and 3 does not divide evenly into 16. How about part C? Do you know if 3,544 is divisible by 4? A quick glance will tell you yes, because the last 2 digits form the number 44, and 4 divides into 44 evenly. How about part D? Is 3,544 divisible by 5? If you said no, you're correct, because the last digit is neither a 5 nor a 0. And finally, let's determine if it's divisible by 6. If you said no, you're correct, because to be divisible by 6 implies that it's divisible by both 2 and 3. While it is an even number, it's not divisible by 3. Now let's look at some divisibility tests for the numbers 8, 9, 10, and 12. To determine if a natural number is divisible by 8, you can check if the last 3 digits form a number that is divisible by 8. To determine if a natural number is divisible by 9, the sum of its digits must be divisible by 9. And to determine if a number is divisible by 10, the last digit must be 0. And finally, in order for a number to be divisible by 12, it must be divisible by both 3 and 4. So let's check. Is the number 3,784,192 divisible by 8? The last 3 digits form the number 192. We need to check if 192 is divisible by 8. Since 8 goes into 192 24 times with a remainder of 0, 192 is divisible by 8, and the given number is also divisible by 8. Is this number divisible by 9? To determine that, we need to analyze the sum of the digits. The sum of the digits is 30, which is not divisible by 9. So this number is not divisible by 9. Let's check if this same number is divisible by 12. To be divisible by 12, it must be divisible by both 4 and 3. Let's check divisibility by 4. For that, we analyze the last two digits, which are 92. Since 4 divides evenly into 92, the number is divisible by 4. Now let's check divisibility by 3. For this, we need to find the sum. The sum of the digits is 30, and 3 divides 30. So yes, not only is it divisible by 3, but it's also divisible by both 4 and 3, so it's divisible by 12. Finally, let's test if this number is divisible by 10. The answer is no. Since the given number doesn't end in a 0, it is not divisible by 10. I hope you found this video helpful. If you did, please remember to give it a thumbs up. That helps other students to find the video.